Hello everyone and welcome back to my channel. In today's tutorial, you will learn how you can implement a basic enemy AI in Unreal Engine 5. You will learn how you can utilize the pawn sensing component to create your enemy AI. Also, you will learn how you can implement the behavioral tree for your enemy AI. So without further ado, let's get started. So here I'm in the basic game animation sample project template, and I've actually downloaded the Shinbi character from the Epic Marketplace. So here I have the Shinbi character, so Paragon Shinbi. If you go to the characters, heroes Shinbi, we have the basic blueprint and its animation blueprint of this Shinbi character, and we will be creating the AI for this character itself. So you can just load any character from Paragon or any other custom character as well, it will work. So here you will find we have some warnings of the input access, which is not there in this project. So either you can just delete it or you can just ignore it. For now, we are not going to control this NPC with our controller. It's going to be controlled by an AI, right? So yeah, we do need the blueprint class and we have the anim blueprint as well. So again, if I open up the blueprint, you will find there's a mesh, and the anim class which is linked with this mesh is the anim blueprint. So you can just drag and drop this AI blueprint, and I can just rotate it towards my character. My character is the Wukong character which I have used in my remake. So here is the character, and what I will do in this tutorial, that instead of my actual remakes enemy, I'm going to recreate the enemy AI for the Shinbi character. I have created for a different character. I guess the name is Morikesh. So if I go over here, yes, so I have created that for the Morikesh character. So if I actually go inside the characters, heroes, Morikesh, and if I just drag and drop this enemy AI over here, and let me just showcase you what we will be creating. I actually need a nav mesh. Over here I will go all classes, so navigation mesh bounce volume, and what we will do is we will just scale it in this axis. If you press P, you can visualize the total area in which the AI can move. Alright, so now if I press play, and actually there's the start animation of that character. So as you can see, the character, the AI is following us, and when it reaches near us, the AI is start attacking. Alright, so we are trying to achieve the same thing for this Shinbi character. So that is what we are going to recreate now. So let's open up the character blueprint of the Shinbi character, and to actually add the pawn sensing, you can add that inside the components and find pawn sensing. So this is a component which gives the sensory benefits to this character, and what you will find is there's few threshold and spherical radius. You will find it is actually hearing threshold, sight radius, and the angle, the peripheral angle at which the AI can see. So over here it is set to 5000, the radius. Actually I can reduce it to 1500. I can set the angle at which this is the field of view. I can set it to 45. So only inside this range this AI will now be able to detect something. And how it will be detecting is with the help of this event which is called as on C pawn. So let us quickly add this event. And so as I said, the pawn sensing will give the actually sensing of this character. It will convert the basic character to an AI character. Alright, so now the pawn will be our character which I want the AI to sense. So which is my Wukong character. So cast to my Wukong character. So what is happening over here is by casting our character, we are telling is on C pawn my character. So it is sensed by the pawn sensing, and yep, when this is happening, I can execute something. Let us just first print like sensing. All right. So now my character will be sensed, right? When it is sensed, it will check if it is my character, then it will execute. So that is how it goes. So make sure you have the navigation mesh bounds, and let's hit play, and there you go, it is printing sensing, right? If I go outside of the angle and if I come again, you will see it is printing sensing, right? So now let us actually add the movement for this character. So to actually detect, now it has detecting, and now to move the character towards my character, how you can move this AI. So we have this node called as AI move to. So with the help of this latent function, what you can do is you can move the AI character to any place in the world, or for this case I want to move it to my character. All right, so we don't have to set the destination if you are setting the target actor. All right, so pawn is self, so get a reference to self, that will be the pawn, and the target actor is the Wukong. All right, so let's hit compile and let us test it out. I'll hit play, and if I go near, you will find now just how the AI is trying to follow me, and it is actually just merging inside my character. So to control that, we have something called as the acceptance radius. So if we suppose increase it to like 200, so that is like a radius or the threshold, so the AI will just stop at the 200 radius from my character. Right, so it just gets teleported. So yeah, this is how the basic AI actually works. And yeah, you can just set the peripheral vision. Right now it is 45, so hence I can just, you know, try to go around of this character and no longer it follows me. Right, now to actually add the movement in this character, you have to do certain changes inside the animation blueprint. So currently, if you open up the anim blueprint, right over here, we have the anim graph over here, and also we have this event graph. In the event graph, I actually disabled this node, which is actually the start animation it was playing. All right, so right over here inside the anim graph, you will find that we have the ground locomotion, we have this locomotion plus anim offset. So all of this was meant to be controlled using a player controller, but currently we are using this for the AI. So we'll have to create our own blend space. So now what is blend space? This is how we will do the transition from one animation to another animation using a variable to control it. So you can just right click and go to animation over here and click on blend space. So there are two kinds of blend space. One is a 1D blend space, and other one is you can have multiple parameters over there, X and Y axis. So blend space 1D, and here you have to select the skeleton, which is in my case Shinbi skeleton. All right, so over here I will write blend space 1D. I'll write like Shinbi underscore idle to run underscore blend space 1D. All right, now I'll just open this up. Right over here you will find a horizontal axis, which is here that you can see. I will set this to speed. You can give it any name. So but we are actually controlling the speed of it to make it animate, and to actually so first we have to add the idle animation here. So I will drag it and drop it at the 0th value. So currently whatever speed it is, right, whatever speed. Now how the speed is being calculated, if you may ask, if you go inside the event graph over here, you will find this is where the speed is getting calculated, and where the speed is we are getting from is actually the character movement right over here. Here the max walk speed is set to 400. I have set it to 400 right over here. So over here also the maximum access value, the maximum speed for the animation also I will set it to 400. All right, and right over here it would have been nice if we had walk animation and run animation, but unfortunately over here we just have a normal jog animation. We can click drag and drop this jog forward animation. Let's drag and drop over here, and I can control this timeline using the left control key while holding it. So when I am at 400 speed, I can go in this animation. I will also put it right over here. So as you can see, when I have achieved 200 speed or even 400 speed, I'll be performing this animation. All right, so that blend space, now we have to add it inside the anim blueprint. So I will go back to the anim graph, and over here instead of ground locomotion, we do not need it because we are not controlling anything over here. And you can just drag and drop your blend space right over here. This is the blend space, and we want to actually get the speed, and according to the speed we will do the animation. So we'll get the speed right over here. Okay, and as I said, where is the speed being calculated? Right from here. So we are getting the speed from the character movement, and it is getting velocity, getting vector length. According to it, it is setting the speed, and that speed is we are using right over here. And according to that speed, we are going to set either we are going to play idle animation, or we are going to play at whatever speed it's. If it's 200 speed, then it will be run animation. If it is anything in between, then it will do the transition, which is called blending of the animation. Hence it is called as a blend space. All right, and why it is 1D? Because we are just controlling it in one axis right over here. All right, so I think, okay, here we have to set it. We actually do not need anything else, but for now I'll just keep it as it is. Let's save it and let's test it out. I'll hit play, and as you can see, the AI is now running towards my character. All right, and when it reaches it, it will just stop. And if I go again inside the radius, just like that. All right, also one thing, if you find that your character is actually struggling to rotate smoothly, you can go inside your blueprint class again. Let me actually increase the angle and radius as well. Yeah, so for making the smooth rotation, inside the character movement, just search for rotation. You'll find the rotation rate. Here I have set it to -1, and this would have been already set to true. And this one, use controller desired rotation, set it to true for making for smoothing the rate of change of rotation. All right, so that is what you have to do for achieving a smooth rotation of this AI character. All right, so it just got teleported again. Yeah, so you will find it will be rotating smooth. All right, so yep, that is how you can actually implement this using pawn sensing itself. So next we will be implementing this with the help of the behavioral tree. We will also add random points for it will randomly look around when it is not being seen by my character. So okay, so now we'll go ahead and implement it with the behavior. Okay, so now for the behavioral tree, we will not be using pawn sensing. So let us just I'll just delete this node, and I'll delete the pawn sensing from here itself. Okay, so we'll be creating our own AI controller. So how you can add your AI controller? Go inside your blueprint over here, and here search for AI, and scroll down. You will find AI controller class. So here we'll be creating a new AI controller class. So right click over here inside the create a blueprint class, and here search for AI controller. So found the AI controller underscore Shinbi, or actually Shinbi. Let me try to keep the naming conventions same. Okay, so Shinbi underscore AI controller, and inside here we will be using AI perception. So this is a different method of implementing AI. Either you can use pawn sensing or you can use AI perception. So AI perception is a bit advanced because it gives more flexibility as well, but the pawn sensing is a bit easy to use. So inside this AI perception you will find over here senses config. Over here you can add sensor, which would you like to use. So I would like to config AI sight, because currently we are just working with the sight, the range. So over here it's all the same things. So sight radius, we have the loose sight radius, which is actually important to us. So sight radius is where the actual radius, if we get inside of the radius, it will be detected, and the loose radius is actually a threshold it is keeping. So let us keep this to maybe like 2000 and 2500, and the actual angle, let's set it to 60. All right, and over here detection, detect by enemies. For that we need to actually create a class of enemy, but let us detect neutrals. By default it will be detected by all. I mean, the AI will detect all of the characters. Actually, it's something like that. Okay, so now let me hit this compile, and so here we have the AI controller, and inside this AI controller we want to use this AI controller with a behavioral tree. So in the begin play you will type run behavior tree. So for this, now we need to create a behavior tree asset. So right click and inside artificial intelligence behavior tree, and you can write Shinbi underscore BT. Okay, so now what is this behavior tree? And you'll also find right to your right hand side is something called as blackboard asset. So we do also need a blackboard asset. You will find that this is my pre-made blackboard asset for my Wukong game. We have some variables for this. So let us first create a blackboard asset. Right click again in the artificial intelligence blackboard. So BB so Shinbi underscore blackboard. All right, so over here I will select Shinbi underscore blackboard asset. Over here now we do not have any keys, if you find over here. So inside the behavioral tree you will have the behavioral tree itself and also something called as a blackboard. Okay, so now let me first cover what is this blackboard. So blackboard is nothing but where you will define all your keys. Keys nothing but your variables that you will control, and where you will control it inside your behavioral tree. All right, you will define your variables in the blackboard and you will use them inside your behavior tree. But where do you set those variables? You can set it inside your player controller, or actually we'll be setting inside our AI controller because we are using AI perception over here. You could also use AI perception right over here itself. You can add it, but we are making the AI controller class, so it will be making sense to actually do everything right over here. All right, so inside the behavior tree what do we have? So we have this root component right over here. You will find inside the root component we have the blackboard asset. Okay, so this root components will hold, it is actually the root of the tree. Imagine it actually the upside down tree. Okay, and this tree, what it does, it executes from left to right. Okay, our blueprint flow is, of course, it is from left to right as always. So you can drag from here the arrow and you will find three components. One is the selector, one is the sequence, the third one is a simple parallel. In this lecture we'll consider only two of them, selector or sequence. Okay, so let's learn about both of them first. What is the selector component? Selector nodes execute the children from left to right and will stop executing its children when one of the children succeeds. If a selector's child succeeds, the selector succeeds. If all of the selected children fail, the selector fails. Alright, what is the sequence? Sequence nodes execute their children from left to right, it's the same, and it will stop executing its children when one of their children fails. If the child fails, then the sequence fails. If all the sequence children succeed, all of the sequence succeed. So that was just the theory. We'll try to understand it with practically. Okay, so now you will find that the root node will only be connected once. It will only be connected to one component. All right, so in the layman's term, the selector will select either the left branch or the right branch. The sequence will run one by one. So here we can connect more sequence, here we can connect another sequence, something like this. And the selector over here, let's add a sequence over here, and let's add a sequence over here to make you understand. So the selector, what it will do, according to few conditions, either it will select this left part, left tree, or it will select right tree. If this tree is not executed, if it is still true, it will only run this, unless and until there is some condition to make it to the right hand side. Alright, what sequence will do, it will execute this one, then it will execute the second one, then it will execute the third one. Alright, you will find the execution index right over here, 0, 1, 2. Let us I will connect the root to the selector first. So now how the execution index goes is 0, then 1, then 2. Alright, here again you can add more sequence. So 0, 1, 2, you'll find 3 is over here. Again, let's add more sequence. So 0, 1, 2, 3, and now it is 4. So it goes by left to right. Alright. So now let us add the AI functionality over here. So for that, we have something called as tasks as well. Before that, okay, so let's understand what are the tasks first. So here we cannot add the blueprint nodes, right? So to actually add the blueprint functionality inside here, you can add tasks. So behavioral tree task, you can create the base behavioral tree task, BT task. So the idea is, what we will do is, if the character is not being seen, if our character is not being seen by AI, we will move the AI randomly. Okay, and when the AI sees our character, then the AI will move towards our character. Alright, so what we will write, behavioral tree task, will make it random roam around. Alright, so when you open it up, you will find it is just like a blueprint. Alright, but you will find that there are no execution nodes, nothing. So for that, you have to write receive event receive execute AI. So this is the start, the tick start node for this over here. Alright, so right over here, you can add what is our controlled pawn. So from a control pawn, which is our AI over here, we can get actor location of our AI. Alright, and from here we have one interesting node called as get a random reachable point in radius. Alright, so reachable point in certain radius. What radius we can provide here, like 500. Alright, and then we can move our AI. So here, from here, AI move to, we'll select this node, and this is our pawn. Over here we do not have any target actor. There's no target actor to move our AI towards. We are randomly moving to a certain destination. Alright, and the acceptance radius, you can set it to anything. Alright, so suppose you this is the task that we have to perform, and right over here we can add that task. Actually we have to add a sequence first, and from here we can add like roam around. Alright, So let's test this out. Okay, so here we have the behavioral tree. Let's get back over here inside the AI controller. Make sure you set your behavioral tree right over here. Alright, so everything else is set. Let us test it out and we'll try to visualize what happens. Okay, so currently let me select for the debugging. So the Shinbi player, alright. Okay, we missed one thing, that we created our AI controller but we haven't set it right over here inside the AI controller class. So make sure you set your AI controller class right over here. That's why we were not able to detect automatically. Okay, so now let's hit play. Now it is randomly just moving here and there, right? So you can also visualize what the AI is actually seeing using this shortcut key of apostrophe. Alright, and you will find over here you want to visualize nav mesh, you can press the numpad 0. AI, it is already visualizing. Behavioral tree, it is visualizing right over here. This one, you can visualize abilities, perception system, and EQS as well. So you can press the key what you want to visualize and what not. All right, so 3 4 5 6. So it is actually also visualizing our where our character is as well, right? But it is not actually following us. All right, so you will find it randomly came to one location and it got stuck. Why? Because it is actually, we haven't added the finish execute node over there. So we actually have to add the finish execute node to tell that our task is finished. So on success, you have to write finish execute, and we have to tick success to true. All right, so after this, let us try to visualize, debug this. So there you go. Now after it finishes one point, then it goes over there and it goes and so on. What you can do in the sequence is one interesting thing. After, if you want to add a break, right, if you want to add a delay, like it has reached one destination, you want you to wait. So in sequence, what you can do, so once this get executed, if you do not have anything to the right, so sequence will again execute from the start. So there's something called as wait that you can use. All right, so here wait for maybe like 3 seconds we can keep, right? So 0 1, it will roam around, then it will wait for 3 seconds, then it will go back again to the sequence, then it will roam around somewhere, then it will wait for 3 seconds. So this is how it will go now. So let's hit play. So it goes around, it waited there, it will wait for 3 seconds, it will roam around again, wait for 3 seconds, and it will go. So this is how this sequence works. All right, so now let us create a sequence for it to move towards my character, and then we will go towards the selector. All right, so now let's create another sequence. It will automatically detach this, it's fine. Okay, so right over from here, to make the AI move, of course we are going to use AI move too, but for that we need a different task. All right, so new task, blueprint base, and right over here Shinbi move to. All right, and same thing, right click, execute, receive execute AI event, and this one what you need to do is same, you have to AI move to the pawn, and what is our target is our get player character, which is our player Wukong. All right, and here the acceptance radius you can keep, of course, like 200, and on success we do not forget to finish execute. It depends upon what you're trying to do with the AI. According to that, you can either finish execute or not. All right, now let's head back, and right over here you can weekly task should we move to. All right, so let's test this out now. And the AI, yep, it is moving towards my character just like that, and it will wait in a certain radius, in the acceptance radius. So this is how we achieved the same thing in the pawn sensing, right? But now we are going to use Selector, which will let us decide whether you want to roam around or would you like to move towards my character. All right, so let's do that. So now let us add the selector. So from here we can get the selector and this sequence, and over here we are just moving and we do not have anything to wait over here, so we do not need a sequence right over here. All right, so now how the selector will work? Will it work just like that? No, it will not. It will just loop to this one, right? And it will never execute this one because there are no condition, and this will never get false actually, right? When it gets true, it will just loop and loop. All right, so now to make the selector work, we have to go to the blackboard over here, and over here we need to create a variable, and we will control that variable. According to that variable, we can set the condition inside the behavioral tree to either execute this or this. All right, so let's go to the blackboard over here, create a new key, and we'll create a boolean right over here, and we'll say it, we'll call it maybe like has seen player. All right, or maybe can see player, sounds better. Okay, so this one, what you need to do is go inside your AI controller, and inside the AI perception, here we have to set the can see player true or false. All right, now how can we set it? Over here we have the events. So there was the event in the pawn sensing called as on see pawn, right? Over here we have on target perception updated, right? We are going to use this on target perception updated right over here. In the stimulus, we are going to split this, and you will find stimulus successfully sensed. This one we are going to use. All right, and right from here we are going to get the actor, and we are going to cast to our Wukong character right over here, and here to actually update that variable, that boolean, we are going to get blackboard. All right, and we are going to set set value as boolean. Okay, now we're going to get this over here. If it is successfully sensed, then we can update this boolean. And which boolean we want to update? It is set name, set literal name, make name. Yep, this one. And just make sure you just get the exact name. Press F2 to select the text and just copy it. All right. So what this will do is it will on target perception updated, right? This one we have on target perception forgotten, on perception updated. Mainly on target we are focusing. So, and the actor is a Wukong actor, right? And when it is updated, it will when it is sensed. Also, yeah, one thing I would like to show, I'll just detach this. I would like to show how you can visualize that. So it is not moving, right? Let me go back over here. Actually, I want you to see how this executes. All right. I should move towards here. And if I do the apostrophe and let me enable all of them, 3, 4, 5, and 6. Right. And you will find that how the character is looking at me, and look at the radius. Actually, I try to run away, and yeah, it has stopped. Right. And if I come back, I think here the nav mesh bounce is finished. So yeah, that is how you can visualize. That is what I wanted to show. We are going to use that right over here. Okay, I'll connect the selector here. I'll connect the sequence selector right over here. Remove the sequence. Okay, and I'll connect this cast and set the boolean. And now you may ask, we have to set the boolean right over here, right? As I said, we are defining the variable here. We will be using the variable here, and we are going to setting the variable over here. All right. So over here, to actually set as a condition, we are going to use something called as decorator right over here. Add decorator. There are multiple kinds of decorator. It is actually nothing but a condition, right? Condition for the selector to select this part or that part. All right. So add decorator, we have multiple. There's a cooldown, there's a loop, and these are all the predefined ones. And if you want to use a custom one, for our case, yep, we are going to use a blackboard variable, right? So blackboard based condition. Here you can set roam around. This is just the name. All right, roam around, and over here you will find a key query. Key query is actually, because our key is a boolean, we can set it true or false. Here you can find can see player. So here, as we have defined, right? So can see player, click over here. If can see player is not set, means we are not the AI cannot see player, then we want the AI to roam around and just roam around, wait. Over here also we are going to add the decorator of a blackboard, and over here can see player, if it is set to can see player, right? If it can see the player, then I want it to move towards my player. Let's test this out, what happens. So over here, if I press play, and let me visualize this. All right. So now you'll find it is just moving around. I'm inside of the radius, but not in the peripheral vision. Actually, if I try to come inside the peripheral vision, all right, well, you will find it is trying to catch. And let us try to go outside of the peripheral vision now. Vision, there you go, almost outside. If I go outside of the peripheral vision, you will see that the character is still trying to catch us, but we are outside of the vision. Now we are totally outside of the vision. Okay, so we might have to reduce the radius, but you will find it is still stuck right over here. It is not roaming around now, so we want it to roam around. So for that, we have something called as aborting of this the task right over here. So inside here you have notify observer. So what is the observer? Is this one itself, right? Notify this observer on value change. For this we have just one value, right? So on value change of the blackboard, you will find on value change, restart on every change of the observed blackboard value. We want it to, so abort, we want itself to abort. All right, it will itself abort itself. That means it will close itself, right? And it will go back over here. And here also we can set it to self. There is something called as low priority. That means that this one will be set to as a low priority, and this one will get a higher priority. And we also have abort both of them, right? So we can so for now we have to use self right over here and right over here. and this one is move to character. All right, so let's test this out, and I'll hit play. It has seen me already. Let me turn on so that you can see how it is working. All right, so now it is, I'm in the vision, I'm inside the site. Let's try to get outside of this, and let us also visualize this. All right, so currently the AI is moving to my character because I'm inside of the radius still. Let us go outside of the radius a little bit more, and I am almost outside. Yep, and now it is back to roaming around, and if you just see, it will wait and it will roam, as you can see, and it will wait and it will roam unless and until I am back inside of the range of the character. So now if I am, so that is the peripheral vision, I am back inside the range, it is moving towards my character. So yeah, that is actually pretty interesting how it works around. And in the maybe in the next lecture I will create how you can actually, I just got teleported, oops. So in the next lecture I will cover up how you can actually do the attack of the AI as well, how the AI can attack, and yep, that we will cover up. If you have any queries regarding how this works, do let me know. So yeah, of course, the behavior tree is much more larger than just this. This was just a little example, a basic AI example. There are a lot more things that you can do with the behavior tree, which in the future videos I'll try to cover. So thank you so much for watching this tutorial. Let me know what other things would you like to see regarding motion matching or the new mega lights or Unreal, anything specific. Please give me your valuable feedback regarding this tutorial or any other previous tutorials I would like to improve upon, and let me know what more things would you like me to explore and to actually make a tutorial about. Join the Discord channel and provide suggestions over there. So again, thanks a lot for tuning in. Stay tuned for more.